So we talked about constructing confidence intervals for a population proportion. Now we're going to talk about constructing confidence intervals for a population mean. So we need our point estimate, and remember that that is the value of this statistic that estimates the value of a parameter. So when we're looking at population means, our point estimate is X bar. So let's take a look at an example. Construct a 99% confidence interval about the population mean weight in grams of pennies minted after 1982. Assume mu equals 0.02 grams. So we know the population mean is 0.02 grams. And so we collect 17 pennies and we weigh them, and here are their weights. Okay, and so we can enter those into the calculator and get the mean weight and the standard deviation. And so we're going to construct a 99% confidence level, or confidence interval. So that means we're using a 99% level of confidence, so alpha equals 0.01. And so what that means is if we took 100 different confidence intervals, if we constructed those based on different samples out of the population, we would expect 99 of those intervals to contain the actual parameter and one of them to not include the parameter. All right, so just like with our population proportions, we're going to take our point estimate and add and subtract our margin of error. And our level of confidence, as that increases, the margin of error increases. As the size of the sample increases, then the margin of error decreases. And the more spread there is, the wider the interval will be for a given level of confidence. And those are all just the same as with the population proportion. All right, and so when we use the population means, instead of using a Z distribution, we're going to use a T distribution. And it's a little bit different than Z because when we find our T value, it's demonstrating the area, or it's showing the area to the right of the curve, to the right of that T value instead of to the left like we used for our Z distribution. Okay, so the area is alpha, and with the T distribution, it's the area to the right of our T value. All right, so let's take a look at how we solve this problem. So we find our T value is 1.746, and again, you can use the calculator to find that if you have the updated version on your calculator, or if you don't have an updated calculator, you can use the T table. And then we need to use find our E, our margin of error, and we use this formula to find that. Or we could just do it all on the calculator. And then we take our point estimate, which was the mean, 2.464, and the calculator will give that to you. And you will add and subtract your margin of error. And so we end up with this interval of 2.456 to 2.472. So we can say we are 99% confident that the mean weight of pennies minted after 1982 is between 2.456 and 2.472 grams. All right, so now let's take a look at another example, but this time we're going to find what size sample we need, just like we did with the population proportions. So we're going to take a look back at the pennies, and we're going to ask how large a sample would be required to estimate the mean weight of a penny manufactured after 1982 within 0.005 or 5/1000ths of a gram with 99% confidence. And we're going to assume that the standard deviation of the population is 0.02. All right, so what we're going to do is use a formula that's similar to the one we used with the population proportion, but not quite exactly. Now, keep in mind here that although with population means we use a T distribution and not a Z distribution, when we're trying to estimate the sample size, we have to use Z because T is based on knowing exactly what size the sample is. And we talked about that when we used degrees of freedom in class. And so you need to make sure that you're using Z in this formula instead of T. Okay, and then we're going to round N up to the nearest whole number. All right, so let's take a look at our solution. We know that E is 0.005, because the problem told us that, and we know our standard deviation is 0.02. We knew that we wanted a 99% confidence, so that means that alpha is 0.01, so half of that is 0.005, and so when we use the inverse normal function on a calculator or you use a z-table, you get 2.575 as your z score or z-value. And so then you can just plug those values into the calculator, and we know we need to round up, so we would need 107 pennies in order to be able to construct a confidence interval that was 99% with level of confidence within 0.005 grams.